Okay, so let's suppose that we have a parabola, y equals x squared. And it's a pretty cool parabola, but it's kind of boring. Suppose we want to rotate this 45 degrees counterclockwise. So basically positive 45 degrees. How can we do that? Well, I think one way we could do this is to tackle this using vectors. Because you see the vector function of a parabola, of this parabola, like if we have v of t, right, where v represents like where all the tips of the vectors land, right? So we have that v of t is equal to t and t squared, right? X component is t, y component is t squared, right? So this vector function is going to represent all the vectors that just land on this parabola. Alright, so what's that going to do? Well, we know how to transform vectors, or transform vectors, right? Because we know about the linear transformations and the stuff we can do with matrices and all that. And we know how to transform a vector. We know how to rotate a vector 45 degrees using matrices, right? Because we have our basis vectors right here, I hat, and our j hat, right? I hat is 1, 0, right? And j hat is 0, 1. We know exactly how to rotate these for positive 45 degrees because we know where I hat and j hat are going to land. I hat, this is I hat, right? I hat is going to land, let's see here, magnitude remains the same. So it's going to land at about cosine 45 and sine 45, right? This is just simple geometry. Right, this is where I hat is going to land. Simple unit circle stuff. J hat is going to land at cosine, well, we already have 90 degrees right here. So 90 plus our 45, cosine 135 and a sine 135, right? So we can simplify this a little bit. Cosine 135, let's think about this. That's about 45 in this direction. So 45 in this direction, right? So we can say negative cosine of 45, negative 1 over root 2. Sine of 135, let's think about this. Sine of 135, this is here, 45 here. That's the same thing as 45 here. I'm just doing math at this point. That's the same thing as sine of 45, which is 1 over root 2. Cool. Close that. Let's see here. And cosine 45, we know this is 1 over root 2. Sine of 45, same thing as cosine 45, 1 over root 2. Alright. So this is where j hat goes, this is where I hat goes. We can encapsulate this transformation in a matrix by having this matrix. So 1 over root 2, 1 over root 2, and negative 1 over root 2, and 1 over root 2, right? So this is our transformation matrix. This column shows where our basis I vector goes, basis vector I hat goes. Column shows where basis vector j hat goes. If we multiply this by our vector function, our v of t, so by t and t squared, we will get a new vector function. I'll keep this 0. We'll get a new vector function, vt of t. That's going to describe where, hopefully you can see, this is going to describe where our rotated parabola, well, describe the vectors that land in our rotated parabola. So if we do matrix multiplication here real quick, we'll get our new vector function. So let's see here. We're going to have, let's see here, rows by columns, right? So we're going to have a 2 by 1 matrix, 2 rows, 1 column. Yep, 2 by 1 matrix. So let's see here. Our entry is going to be t over root 2 minus t squared over root 2. So t over root 2 minus t squared over root 2. Let's fix that. 2 over 2 minus t squared over root 2. Second entry is going to be t over root 2 plus t squared over root 2. T over root 2 plus t squared over root 2. That's going to describe our new transformed vector function that maps to our rotated parabola. Now, if you want to plot this on Desmos, we can just rewrite this parametrically, it doesn't matter. You can rewrite this as t over root 2 minus t squared over root 2, comma, t over root 2 plus t squared over root 2, right? This is just x of t, this is y of t, right? You know the drill. So we can rewrite this parametrically and plug this up on Desmos. So we should see a nice, very nice rotated parabola, rotated positive 45 degrees. So pretty simple problem, I think. interesting use of linear algebra, matrices and stuff like that. So if you like this video, follow for more things like this. If you have any feedback, leave it in the comments. I will see you in the next video, whenever that may be.